Guys, so today we're going to talk about the properties of logs. So I want you to try these two warm-ups from our lesson yesterday. Warm-up A is what question is log asking? And then warm-up B is to evaluate this log without your calculator. So I'm going to give you a few minutes to think about that and to talk with your partner. Okay, so let's talk about these two things first. What question is log asking? Log is asking your base to what power equals the number. Okay, that's what you're asking. The base to what power equals our number. So here, if we're looking at part B, the question we're asking is 3 to what power is 729? So 3 to what power is 729? And that is 3 to the 6th power. Okay? Alright, so let's talk about these product rules. And so you'll want to write these down, these properties of logarithms. These are the rules we're going to be doing today. Whenever you see a log of two things being multiplied, remember that product means multiply. So I'm looking at this u and b being multiplied. I'm going to rewrite those. This is called expand. I'm going to expand this log base b of u plus log base b of v. So whenever I see multiply, those are going to change into plus signs. Okay? So you can kind of guess. Quotient means divide. So what am I going to change a log division into? Well, if multiply is plus, then log base b of u divided by v is log base b of u minus log base b of v. Okay, so quotient divide turns into a minus. Okay, and then a power, this one turns into a multiply problem. And here's what's going to happen with that power. We are going to pull that power out to the front, and it looks like this: in log b of u. Okay, so now we're going to start breaking these apart, and let's look at a couple of these examples right here. Okay, we're going to try some of these, okay? So first question you have to ask yourself is what's going on between this 22 and this x, okay? And this ln is just natural log, okay? It's another button on your calculator, but we're going to talk more about the natural log on its own day. But if we ask ourselves the question, what's going on between the 22 and the x, the answer is multiply. So I know that all multiplies turn into additions. So this is the same as natural log of 22 plus natural log of x. Okay? Alright, let's talk about b, because b is interesting. You have to ask yourself, what's being raised to the 4 power? And in this case, it's only the x being raised to the 4 power. Okay? So we can't pull the 4 out first. We have to break apart the 3 and the x and then pull the 4 out first. So it looks like this. Log base 7 of 3 plus log base 7 of x to the 4th. And then I still have one more thing that I can do, and that's to pull that 4 out to the front. So it looks like this: log base 7 of 3 plus 4 log base 7 of x. okay? So you kind of have to do order of operations and look at what's going on, all right? I would like for you to try C, because C kind of combines A and B together. We have a multiply on the top of my fraction and an exponent, so that one matches what we did in B. And then we have a divide, and then we also have a power down in the denominator. So I'm going to give you about a minute to try that one. And if you're feeling ambitious and you think you got C right, try D. All right, let's look at C and then we'll talk about D. So the first thing that I'm going to do is pull apart this division right here. So log base 2 of 7x to the third minus log base 2 of y to the fourth. Okay? Now I'm going to have to pull this part apart because there's more stuff, and then of course the 4 has got to come out in front of my log. Okay? So let's pull apart this. We're going to group those because those are being multiplied together. So log base 2 of 7 plus log base 2 of x to the third, group together, minus, pull that 4 out front, 4 log base 2 of y. Okay? Then I still have one more thing to do, and that last thing is to pull this 3 out to the front. So I have group log base 2 of 7 plus 3 comes out front, 3 log base 2 of x minus 4 log base 2 of y. Okay, so you have to be careful and kind of go backwards order of operations a little bit. Okay, now I want to show you a little trick on D, because once you rewrite D, it becomes really easy. All this 16x to the third is all of that is under the radicals. So I'm going to rewrite. Remember that radicals are the same as fraction powers. So we have 16x to the third really to the 1/4 power. Now once I write it like that, that allows me to pull that 1/4 out front. Okay, so now I have 1/4 natural log 16x to the third. All right, I'm going to give you about 30 seconds. I want you to see if you can pull this part apart. All right, let's try to do that. Now remember that 1/4 goes on all of that stuff. Okay, so that 1/4 needs to stay out front. I'm going to see if we can do it in one step. 1/4 natural log 16 plus, now remember this 3 has to come out front, 3 natural log x. Okay, so the 16 and the x to the third are being multiplied. That's, we changed to a plus, and that 3 exponent is coming out front. Okay. All right. Now let's try going the opposite. We're going the opposite direction from what we did have, okay? So let's try A and B, and then I'm going to let you try C by yourself. So let's look at A. Remember that all minuses turn into division. So I really have natural log of 16 divided by 4. And then if we can simplify, we want to. What is 16 divided by 4? That is the natural log of 4. And you don't have to have the parentheses like what I have, okay? All right, let's look at the next one. Remember that numbers out front need to be pulled back up to the exponent. Okay, so I really have log base 16 of 12 to the 4th divided by, minus turns to division, remember, 2 to the 4th. Okay, so now go to your calculator and let's simplify that inside. Okay, so I have log base 16 of I got 1296. Did you guys get that? Okay. All right, I want you to try C by yourself. Try C by yourself. Remember what plus turns into. All right, so let's talk about what you did. So first off, that 1/2 needs to pull up here, okay? And then we need to remind ourselves what a 1/2 means, okay? So we have log base 3 of 2 times y to the 1/2. Well, what is y to the 1/2? Y to the 1/2 is the square root of y. So we want to write it like that, not to the 1/2 power. Okay. All right, let's look at this last one. Okay, lots of stuff going on here. So first of all, let's pull our 1/4 up here, but let's remember that is log base 5 of the 4th root of 81, which I think is a perfect fourth, so we'll figure that out in a minute. Minus means divide, okay, and then I've got a 2 pulling up and a 1/2 pulling up, okay? So on the bottom, I have log base 5 of 6 to the 2nd power, which is 36, divided by 4 to the 1/2, which is 2. Okay? Now, let's see if we can condense this a little bit more. Log base 5, the 4th root of 81 is 3. 3 to the 4th power is 81. 36 divided by 2 is 18. Okay? Which does reduce one more time. That is log base 5 of 1 over 6. Log base 5 of 1 over 6. Okay, so we want to try to get it down to 1 log if at all possible. Okay? All right. Now we want to do a little bit of evaluating, okay? And this is evaluating using our properties that we just talked about. Okay, so let's look at the first one. Remember that the times symbol means add, so I can rewrite this one. Log base 2 of 4 plus log base 2 of 16. Now why would I do that? Okay, well remember what we talked about yesterday. Log base 2 of 4. 2 to the what power is 4? Well, that will be 2. 2 squared is 4. Plus 2 to the what power is 16? That's what you're asking yourself there. And that's 2 to the 4th. So I end up with 6. Okay? Alright. Now let's look at this next one because this is a little bit interesting. Natural log is log base e, okay, of 1. And then remember that dividing signs, I made up a new word, division signs turn into a minus natural log of e to the 3rd. Okay, now we got to do a little bit remembering about our properties. 1, natural log or log of 1, the only thing you can do is 0. E to the 0 is 1. Remember, that's the only way you can get 1 is to raise it to the 0 power. Minus, now you should remember this from the other day. What do these guys do? They cancel each other out and I'm just left with 3. What is 0 minus 3? Negative 3. Okay? 0 minus 3, negative 3. Alright? I want you to do some expanding on C first. So try to do some expanding on C. Alright, so I hope when you were looking at this to do the expanding that you pulled that 3 out front. So that's 3 log. Remember, when it doesn't have a base, it is base 10. Okay, and then I have 0.01. Okay, now I want you to do a little bit of thinking for me. What is 0.01 in relationship to 10? Okay, 0.01 is 10 to the negative 2. Okay, so then use the same thing that we did in B. These guys cancel, and I'm left with 3 times negative 2, which is negative 6. Okay. So got to remember some properties of logs there about this, that the log base anything of 1 is 0, and then we have a log base 10 of 10 or a log base 3 of 3 or a natural log of e. Those are going to cancel each other out. Okay? Alright, now we're going to evaluate. Evaluate using we're going to work on our calculator a little bit. Okay, so pull that calculator out. And we've got to talk about how to type these in. Okay, these guys are easy. They are just the regular log button on your calculator. Okay, just the regular log button. So you can literally type in on your calculator exactly how it's written. Now when you hit the log button, what it's going to do is it's going to do a parentheses for you to put the number in. Okay, so go ahead and try log of 3. Okay, I got, and we'll round to 3 decimal places, 0.477. Okay, all right, try the other one. Here I got, let's check our answers together. Check with your neighbor real quick and make sure that you all have the same number on your screen. I got negative 2.097. Okay. Now, what if it's something besides base 10? Because both of these guys were base 10. Base 10 base 10, or ln, the natural log, you have that button too. Well, we have what is called the change of base formula, okay, and that's this formula right here. If I have log base whatever of whatever number, I can use b to be any base that I want. Well, what base would I use? Well, base 10 or base e, because that base 10 is my log button on my calculator. Base e is my natural log button on my calculator. Alright, so we're going to use the change of base formula to evaluate to 3 decimal places. Okay? Alright, so I'm going to show you how to rewrite the first one, and then you're going to try the other 3. Okay? So when I go to my calculator to evaluate this, I am really evaluating log base 12 log of 12 divided by log of 7. That's what this formula says. See, the base comes down to the bottom, the other number comes up to the top. We're using base 10, which is our normal base on our calculator. You can use ln. You'll get the same answer, which is really cool. Okay, so now go to your calculator and punch that in. Alright, I'm punching mine in right now. Compare calculator screens, and just for the fun of it, since you're in there punching, do the other operation, do natural log if you didn't do natural log, and try it ln 12 divided by ln 7. Okay, we're doing 3 decimal places, so I got 1.2. Ooh, that gave me a lot of decimals. Hold on. Try that again. Alright, 1.277. Okay? Alright, I want you to try the next 3. So try the next 3 for me. Rewrite it in change of base formula, and then go to your calculator. Alright, when you're done, you check with your partner before looking up at my screen, because I'm going to start writing answers. Alright, now you can look up and see, check yours with mine, and that is not an extra decimal place in there. I don't know why my pen is wanting to do. I switched pens so you wouldn't hear the clicky, and now I'm getting extra decimal places. Okay? Alright, you should be ready to do, at this point, a 4.3 on your assignment sheet, and I will see you guys tomorrow. Be ready for questions. If you are not done with 4.2, please finish that one first before going to 4.3, and we will do questions on both of those tomorrow. I will see you then.